Hello students. Today we are going to talk about dietary fiber, classification of dietary fiber, its composition and nutritional significance of dietary fiber. The objectives of today's topic are to make sure that the students understand the definition of dietary fiber, classification of dietary fiber, composition, and to understand its significance in the human health. To start with the introduction, dietary fiber, it has a long history and its term originating from Hispley in 1953, who coined the term dietary fiber as a non-digestible constituents making up the plant cell walls, and further its definition has been several times revised. Botanists define dietary fiber as a part of plant organ, chemical analysts as a group of chemical compounds, consumers as a substance with beneficial effects on human health, and for dietetic and chemical industries, dietary fiber is a subject of marketing. Later, dietary fiber was defined as a component of plant foods and includes materials of diverse chemical and morphological structure resistant to the action of human alimentary enzymes. The most consistent definition that is now accepted is dietary fiber consists of remnants of plant cell walls resistant to hydrolysis by the alimentary enzymes of a man, whose compounds are hemicellulose, cellulose, lignin, oligosaccharides, pectins, gums and waxes. American Association of Cereal Chemists in 2000 defined dietary fiber as edible parts of plant or analogous carbohydrates that are resistant to digestion and absorption in the human small intestine with complete or partial fermentation in the large intestine. Dietary fiber includes polysaccharides, oligosaccharides, lignin and associated plant substances. Dietary fiber, although not always defined as such, has been consumed for centuries and is recognized for having health benefits. Soluble and insoluble fibers make up two basic categories of dietary fiber. Cellulose, hemicellulose and lignin are non-soluble in water, whereas pectins, gums, mucilages become gummy in water. The importance of food fibers has led to the development of a large and potential market for fiber-rich products and ingredients, and in recent years there is a trend to find new sources of dietary fiber that can be used in the food industry. Supplementation has been used to enhance fiber content of foods. Supplementation has been focused on cookies, crackers and other cereal-based products, enhancement of fiber content in snack foods, beverages, spices, imitation cheeses, sauces, frozen foods, canned meats, meat analogues and other foods have also been investigated. Coming to the classification and composition of dietary fibers, many scientists suggested several different classification systems to classify the components of dietary fiber based on their role in plant, based on the type of polysaccharide, based on their simulated gastrointestinal solubility, based on site of digestion and based on products of digestion. However, none is entirely satisfactory as limits cannot be absolutely defined. The most widely accepted classification for dietary fiber has been to differentiate dietary components on their solubility in a buffer at a defined pH and or their fermentability in an in vitro system using an aqueous enzyme solution representative of human alimentary enzymes. Thus, most appropriately, dietary fiber is classified into two categories such as water insoluble or less fermented fibers, which includes cellulose, hemicellulose, lignin, and the water soluble or well fermented fibers, which includes pectins, gums and mucilages. The classification of dietary fiber components on the basis of water solubility and fermentability is discussed now. The first component is cellulose. It is a major cell wall component in plants, an unbranched linear chain of several thousand glucose units with beta-1,4 glucosidic linkages. Cellulose's mechanical strength, resistant to biological degradation, low aqueous solubility and resistance to acid hydrolysis result from hydrogen bonding within the microfibrils. Cellulose is insoluble in strong alkali, and there is a portion of cellulose which is referred to as amorphous, that is more readily acid hydrolyzed. Cellulose is not digested to any extent by the enzymes of the human gastrointestinal system. The second component is hemicelluloses. These are cell wall polysaccharides solubilized by aqueous alkali after removal of water soluble and pectic polysaccharides. They contain backbones of glucose units with beta 1,4 glucosidic linkages, but differ from cellulose in that they are smaller in size, contain variety of sugars and are usually branched. They contain mostly xylose and some galactose, mannose, arabinose and other sugars. The third component is lignin. It is not a polysaccharide but a complex random polymer containing about 40 oxygenated phenyl propane units including coniferyl, synapyl and p-coumaryl alcohols that have undergone a complex dehydrogenative polymerization. Lignins vary in molecular weight and methoxyl content. Due to strong intramolecular bonding, which includes carbon to carbon linkages, lignin is very inert. Lignin demonstrates greater resistance than any other naturally occurring polymer. The next component is pectin. Pectic substances are a complex group of polysaccharides in which D-galacturonic acid is a principal constituent. They are structural components of plant cell walls and also act as intercellular cementing substances. Pectin is highly water soluble and is almost completely metabolized by colonic bacteria. Due to their gelling behavior, these soluble polysaccharides may decrease the rate of gastric emptying and influence small intestinal transit time. This explains their hypoglycemic properties. The next component is gums and mucilages. These are the types of plant fibers that are not cell wall components but are formed in specialized secretory plant cells. These are reported to be highly branched polysaccharides that form gels, bind water and other organic material. Gums are sticky exudations formed in response to trauma. They mainly consist of guar gum and gum arabic. Guar gum is a galactomannan isolated from the seed of Cymopsis tetragonolobus. Partial enzymatic hydrolysis results in a product that can be used as a soluble dietary fiber. The physiological effects of this fiber source comply with what might be expected from a soluble fiber. Gum arabic. Gum arabic is exudated from the acacia tree, is a complex arabinogalactan polysaccharide in an admixture with glycoprotein. Mucilages are secreted into the endosperm of plant seeds where they act to prevent excessive dehydration. This was about the classification of dietary fiber and the components of dietary fiber. Now, let us look at the dietary fiber content in various foods. The dietary fiber is naturally present in cereals, vegetables, fruits and nuts. The amount and composition of fibers differ from food to food. A fiber-rich diet is lower in energy density, often has a fat lowering property, is larger in volume and is richer in micronutrients. This larger mass of food takes longer to eat and its presence in the stomach may bring a feeling of satiety sooner, although this feeling of fullness is short term. It is suggested that healthy adults should eat between 20 and 35 grams of dietary fiber each day. Several non-starch foods provide up to 20 to 35 grams of fiber per 100 grams of dry weight. Others, those containing starch, provide about 10 grams per every 100 grams of dry weight, and the content of fiber of fruits and vegetables is around 1.5 to 2.5 grams per every 100 grams of dry weight. It has been reported that cereals are one of the main sources of dietary fiber, contributing to about 50% of the fiber intake. 30 to 40% of dietary fiber comes from vegetables and about 16% from the fruits and the remaining 3% from other minor sources. Now, after looking at the dietary content of various foods, Now let us see the dietary fiber content of various food sources. To start with the dietary fiber content of grains, the first one is barley, which has got 17.3 grams for every 100 grams of edible portion. Corn has got 13.4 grams of dietary fiber for every 100 grams of edible portion. Oats has got 10.3 grams of dietary fiber with 6.5 grams of insoluble and 3.8 grams of soluble fiber. Rice has got 1.3 grams, which indicates rice is a poor source of dietary fiber. Looking at the dietary fiber content of cooked rice, it has got 0.7 grams of dietary fiber for every 100 grams of rice we eat. Whole wheat has got 12.6 grams of dietary fiber with 10.2 insoluble and 2.3 grams of soluble dietary fiber. Wheat germ is a very good source of dietary fiber with 14 grams for every 100 grams of edible portion, out of which 12.9 is insoluble and 1.1 is soluble fiber. After the grains, let us look at the legumes and pulses sources of fiber. The beans and green beans have got 1.9 grams of dietary fiber with 1.4 grams of insoluble and 0.5 grams soluble fiber. Soya bean has got 15 grams of dietary fiber. Peas such as green peas or frozen peas have got 3.5 grams of fiber with 3.2 which is insoluble and 0.3 which is soluble fiber. Kidney beans or canned kidney beans have got 6.3 grams of fiber, of which 4.7 is insoluble and 1.6 is soluble fiber. The lentils like raw lentils etc. have got 11.4 grams of fiber, which is a very good source of dietary fiber, out of which 10.3 is insoluble and 1.1 gram is soluble fiber. Lima beans and canned beans have got 4.2 grams of fiber, out of which 3.8 is insoluble and 0.4 is soluble fiber. We have some other kinds of white beans and other raw vegetables which have a dietary fiber content of anywhere between 5 to 17.7 grams, out of which 13.4 is insoluble fiber and 4.3 is soluble fiber. The fiber content of the beans, it depends and varies from the stages of maturity, and they differ at each stage of maturity. Now coming to the other sources like vegetables, among vegetables, potato skin, it has got 1.3 grams of dietary fiber. So if we consume potato along with the skin, you get some amount of dietary fiber, and if you remove the skin, the dietary fiber is lost. Among the vegetables, we have bitter gourd with very good content of dietary fiber ranging from 16.6 grams of fiber for every 100 grams of edible portion, out of which 13.5 is insoluble and 3.5 is soluble fiber. We have beetroot is a very good source of dietary fiber among all the tubers with 7.5 grams of fiber for every 100 grams of edible portion, out of which 5.4 is insoluble and 2.4 is soluble fiber. Fenugreek leaves or methi leaves have got 4.9 grams of dietary fiber, out of which 4.2 is insoluble and 0.7 is soluble fiber. We have vegetables like lady's finger, which has a fiber content of 4.3, of which 3 is insoluble and 1.3 is soluble fiber. We have a leafy vegetable spinach, which is commonly consumed. It has got 2.6 grams of dietary fiber, out of which 2.1 is insoluble and just 0.5 is soluble. We have other tubers like turnip with 2 grams of dietary fiber, raw tomatoes with 1.2 grams of fiber, green onions, raw green onions with 2.2 grams of dietary fiber, out of which the entire 2.2 grams is insoluble in the raw green onions. We have the other vegetables, eggplant, it is also called as brinjal. It has got 6.6 grams of dietary fiber with 5.3 insoluble and 1.3 as soluble fiber. We have the cucumbers. The peeled cucumbers have got 0.6 grams of fiber. Cauliflower raw has got 1.8 grams of dietary fiber. Raw celery has got 1.5 grams of dietary fiber. Raw carrot has got 2.5 grams of dietary fiber. Then we have broccoli, which is again a good source of dietary fiber. It has got 3.29 grams of dietary fiber with 3 grams as insoluble fiber and 0.29 grams as soluble fiber. After the vegetables, let us look at the fruits, which are again some favorable sources of dietary fiber. First among the fruits is apple. The unpeeled apple has got 2 grams of fiber with 1.8 grams insoluble and 0.2 grams soluble. We have fruits like kiwi, which has got 3.39 grams of dietary fiber. Mango has got 1.8 grams of fiber. Pineapple has 1.2 grams of dietary fiber. Pomegranate is a poor source of dietary fiber with just 0.6 grams dietary fiber for every 100 grams of edible portion, out of which 0.49 is insoluble and 0.11 is soluble dietary fiber. We have other fruits like watermelon, which also is a poor source of dietary fiber, ranging between 0.5 grams for every 100 grams of edible portion. We have grapes with 1.2 grams of dietary fiber, orange 1.8 grams of fiber, plums 1.6 grams of dietary fiber. We have strawberries, which are better off than all the citrus fruits with 2.2 grams of dietary fiber. We have other fruits like bananas with 1.7 grams, peaches with 1.9 grams and pears with 3 grams of dietary fiber for every 100 grams of edible portion. Lastly, we have the nuts and oil seeds. They are again good sources of dietary fiber. Almonds, every 100 grams of almonds has got 11.2 grams of dietary fiber with 10.1 as insoluble dietary fiber and 1.1 gram soluble dietary fiber. The raw coconut also serves as a very good source of dietary fiber with 9 grams for every 100 grams of edible portion, out of which 8.5 is insoluble and 0.5 is soluble fiber. The peanut dry and roasted peanuts have got 8 grams of dietary fiber for every 100 grams of edible portion, out of which 7.5 is insoluble and 0.5 is soluble dietary fiber. Cashew nuts or kaju are again good sources of dietary fiber with 6 grams of fiber for every 100 grams of edible portion. We have sesame seeds with 7.79 grams of fiber, out of which 5.89 is insoluble, 1.9 is soluble. We have flax seeds, which are the richest source of dietary fiber with 22.33 grams of dietary fiber, out of which 10.15 is insoluble and 12.18 is soluble dietary fiber. Let us look into the nutritional significance of dietary fiber. The diets with a high content of fiber, such as those rich in cereals, fruits and vegetables, have a positive effect on health, since their consumption has been related to decreased incidence of several types of diseases, as due to its beneficial effects like increasing the volume of fecal bulk, decreasing the time of intestinal transit, reducing cholesterol and glycemic levels, trapping substances that can be dangerous for human organisms, stimulating the proliferation of intestinal flora. Dietary fiber has established effects on stool and consistency. Thus, the mechanism by which stool bulk and laxation is promoted varies for different fibers. Guar gum is readily fermented by the human fecal microbiota, improves bowel functioning and relieves constipation in patients. Available information also indicates that the incidence of diverticular disease is low in populations ingesting fiber both in vegetarians and non-vegetarians. It has been postulated that the dietary fiber may act as protective factor in cancer of the large bowel by shortening the transit time, thus reducing the time for formation and action of carcinogens. In addition, through its stool bulking effect, fiber may lower the concentration of fecal carcinogens, thereby reducing the amount of carcinogen that comes into contact with the gut wall. There are several studies which have reported that ingestion of certain fiber-rich vegetables was inversely related to the frequency of larger bowel cancer. improvements in diabetic control, and reduction in insulin and sulfonylurea requirements also have been reported in both mild and moderate diabetics on high fiber diets containing a normal or high proportion of carbohydrate. It was suggested that large amount of fiber from fruits, vegetables and legumes is partly responsible for the low levels of plasma cholesterol. Scientists in various retrospective studies observed an inverse relationship between cereal fiber intake and death from coronary vascular diseases. A variety of fiber-rich foods such as wheat bran, oats, soy bran, rice bran, apples, legumes, mucilaginous fiber were shown to reduce the atherogenicity of semi-synthetic diets with or without added fat and sterol. Pectin, guar gum and gum arabic also show a hypolipidemic effect in humans, lowering both serum cholesterol and triglycerides. After looking at the dietary fiber, its classification, components of dietary fiber, content of dietary fiber in foods and the nutritional significance of dietary fiber, let me conclude the session. Generally, the plant material in diet which is resistant to enzymatic digestion is termed as dietary fiber. The various components of dietary fiber are celluloses, hemicelluloses, pectic substances, gums, mucilages, lignin, etc. Dietary fiber is naturally present in cereals, fruits, vegetables and nuts. The diets with high content of fiber have been reported to have a very positive effect on lots of degenerative diseases. During processing, the foods undergo various physical, chemical, enzymatic and thermal treatments which directly or indirectly affect the composition of total fiber. Addition of fiber in breakfast cereals, breads, cookies, cakes, yogurt, beverages and meat products has been reported to reduce the onset as well as progression of many degenerative diseases like coronary heart diseases, cancers, diabetes, diverticular diseases, etc. Hence, conversion of dietary fiber regularly with an average consumption of 20 to 30 grams per day is very essential. Thank you.